catalyst is the name given to substances that increase the reaction rate by reducing the activation energy of a chemical reaction, and after the reaction, no change in its chemical structure occurs. This change caused by the catalyst on the reaction is also called catalysis. The catalyst is both the reactant and the product of a chemical reaction. A very small amount of catalyst is required to catalyze a reaction. Because the catalyst used is recovered, it is actually a profitable process. Increasing the speed of the reaction makes a lot of difference in the commercial sector. Of course, catalysis is not the only way to increase the rate of reaction. We have already mentioned the factors that affect the speed of chemical reactions. A much simpler process, such as increasing the ambient temperature, can also increase the reaction rate. But since reactants that react at high temperature can deteriorate, they can have undesirable effects. At this point, the catalyst comes to an important point, stripping out many other factors. It is a vital process in the chemical industry with its properties. It is estimated that 90% of commercially produced chemicals are synthesized by catalytic process. How does the catalysis system work? A catalyst offers a different way for the chemical reaction to produce the same products by expending lower energy. The energy required for collisions between reactant molecules to be at a sufficient level will be higher than the energy required in the presence of a catalyst in the environment. Catalysis does not alter the chemical balance because it affects both the forward and backward speed of the reaction. It does not change the equilibrium constant. Similarly, the theoretical yield of the reaction is unaffected. Catalyst effect. Take the image above. The goal here is for the boy to throw a basket. In the case of A, on the left side, this is a little difficult. But in the case of B, on the right side, the child will be able to shoot the basket much more easily. The catalyst here is the factor that brings the crucible closer to the child's height by lowering it a little lower. Types of catalysts. A wide variety of chemicals can be used as catalysts. Proton acids are commonly used for water-containing chemical reactions such as hydrolysis and dehydration. Decays used as catalysts include zeolites, alumina, graphitic carbon, and nanoparticles. Transition metals, X. Nickel, is mostly used to catalyze redox reactions. Organic synthesis reactions can be catalyzed using noble metals or late transition metals such as platinum, gold, palladium, iridium, ruthenium or radium. The two main categories of catalysts are heterogeneous catalysts and homogeneous catalysts. Enzymes or biocatalysts can be seen as a separate group or as belonging to one of the two main groups. Separate